Hello, my name is Annalie Shane and I'm a technical field trainer with VIVOTEK. In this presentation, I want to go over the basics when it comes to installing VIVOTEK cameras. I'll go over some of the installation techniques, then show you how easy it is to configure our cameras. I will also go over some of the different technologies that our cameras feature. If you have any questions, please email us at trainingna@vivotek.com. VIVOTEK's outstanding network cameras feature a range of megapixel resolutions, camera dimensions, advanced technologies, and value-added video analytic functions in order to satisfy the needs of a diverse range of applications. Our wide array of choices allows users to truly achieve unobstructed monitoring of wide open areas such as airport terminals, shopping malls, train stations, offices, and more. You can know certain details about our cameras just by looking at the model number. Let's go over how easy our naming rule is. We'll start off with the first two characters. The first two characters are going to determine the model category. If you see FD, then that is for fixed dome. FE is for fisheye. IB is for bullet camera. And then CC is for compact cube. The next character is going to determine whether it has H.264 or H.265 compression. If it is an 8, then it's H.264, and if it's a 9, it's an H.265. The fourth character will determine if it's going to be an indoor camera, if it's a 1, outdoor camera if it's a 3, and if it's a 5, it is mobile certified. We will skip the next characters and go to the last one, which is going to show you the features of the camera. Whether it is extended temperature, then it'll show an E. If it has wide dynamic range or high dynamic range, it'll show an H. P for P-iris, and if it has remote focus, it'll show a T. Now that you know how to easily identify the camera you want just by looking at the model number, let's go over some good practices for whenever you're installing the cameras. For our outdoor cameras, you need to make sure that you're using a wrench to torque down the weatherproofing nut and grommet. Please do not tighten it by hand and think that that's going to be good enough. You want the rubber grommet to bulge a little. Also, remember to use Ethernet cable that is between 5 to 6.3 millimeters in thickness. Here's a quick video showing you how it should look whenever it's tightened down properly. It is also good practice to form a drip loop on the back-end cable. Leakage or moisture can gather in condensation into water drops and run along the cable. A drip loop is going to ensure that no water gets into the camera. When you're ready to close up the camera, before you close it up, take out and throw away the silica gel pack that is currently in the camera and replace it with one of the packs that comes in the tin foil packaging with your camera. Now that we have our camera installed and the Ethernet cable plugged in and powered on with the PoE switch, now we can go on to the networking portion. When a VIVOTEK camera starts up, it looks for a DHCP server to hand out an IP address. If there's a DHCP server available, it will give the IP address and then your camera will be talking on the network. If the server is not available, then the camera will receive an APIPA address, automatic private IP address. You've seen this plenty of times before, 169.254. This address is given out so that the host will still be able to communicate with other hosts on the local network segment that are also configured for APIPA. Now that we can communicate with the camera, we can manually go into the configuration and statically assign an IP address. Let's go over how to get to the networking section in the camera. Using Shepherd, I'm going to find my camera that's on the network, double click, and it brings me into my web UI. I can go to Configuration. We're now going to navigate to Network and then General Settings. Click on Use Fixed IP Address, and now we can set our static IP address, subnet mask, default router, and DNS. Once we click Save, it will save all of this information into our camera, and it will reboot into the new IP address. Now that we have that set up, we can now go back and get familiar with the camera's home page. When you first log in, this is how it will look. You'll have the camera's name at the top. You can resize the image with the resize buttons. We have our configuration area where you can go into client settings, configuration, and change languages. Your live view window and video control buttons where you can take snapshots, pause, record, zoom in, and then pop out to full screen as well. And on the left hand side we have our camera control area where we can zoom in, pan, tilt, and zoom and change our video streams if available. Now let's get into configuration. Inside of the camera's UI, we can go under Configuration. And under System General Settings, here we can rename the camera. We can update the time zone and then set a date and time. Going under System Maintenance, here we can upgrade the camera's firmware. We can reboot the camera and also reset the camera back to factory settings. Image settings is where we can make a lot of changes to how the view of the camera looks. We will navigate to Media and Image. Under the General Settings tab, we can choose whether or not and how to display the timestamp. The power line frequency is to eliminate image flickering associated with fluorescent lights. Okay, the power line frequency for the US is 60 Hz. You can manipulate the orientation of the camera by flipping, mirroring, or rotating. And then here's a chart to show you how each term will change the view. The next technology we'll go over is Smart IR. This will help enhance your image for night scenes. This technology automatically adjusts the IR amplification whenever an object gets too close. To make changes to this, we can go under Media, Image, IR Control, and then we can turn on and off that anti-overexposure or our Smart IR. Let me show you a demo of this feature working. Under Image Settings, we can tune the white balance and adjust the image. In automatic mode, the reference point for white is the brightest point in the image. Because the camera often monitors an area where the brightest point isn't really white, the colors in the image can be far from what we consider real. In order to adjust the value for the best color temperature, you can place a sheet of white paper in front of the lens and allow the camera to automatically adjust the color. If we scroll down, we can get to defog. And defog helps improve the visibility quality of captured images in poor weather conditions like smog, fog, or smoke. And below that is 3D noise reduction, and this is mostly applied in low light conditions. This will help reduce noises and flickers in your image. But when it's enabled in a low light condition with fast moving objects, trails or after images may occur. You may then select a lower strength level or disable the function completely. Here's a demo of the defog technology. And a demo of the 3D noise reduction. Note the differences when compared side by side. Moving on to the exposure tab. We'll start off with fast auto exposure. This function is for whenever you need to monitor fast changing lighting conditions. For example, let's say you have a camera that is monitoring a highway lane or an entrance of a parking area at night. Cars are constantly passing by with their lights on, so it can change the lighting very quickly in that area. By enabling fast auto exposure, it'll help you monitor this area. Let me show you a demo of this feature working. Next, we'll go over exposure strategy. With the measurement window, this function allows users to set measurement windows for low light compensation. For example, where low light objects are opposed against a extremely bright background, you may want to exclude the bright sunlight shining through a building's corridor. Let's see how the exposure changes by adding an inclusion and exclusion windows. BLC is for backlight compensation. And then HLC is highlight compensation. And this is for areas that are overexposed. This will disable Smart IR if you use this, but you can see how it compensates for the highlighted areas. The next part we'll go over is WDR, or wide dynamic range. This will enable cameras to capture details in high contrast environments. You can adjust the strength to low, medium, or high to reach that best image quality. So cameras with the H at the end of it after the dash have the WDR technology, and H stands for high dynamic range, which is the same as wide dynamic range. Here's a demo video showing you the difference between WDR and not having WDR. If you notice, the picture is much clearer and brighter underneath the awning with WDR as opposed to without. And the final tab we'll go over in this section is the Focus tab that is available with our remote focus cameras. Any of our cameras with a -T on the end of the model number have this technology. We'll click on the Focus tab, and I'll show you how you can perform a custom focus. You can choose the location that you'd like to focus in on, and then ask the camera to perform an autofocus on that area. Compression and streams. H.265 compression is available on our 9000 series cameras. So remember, if you see an FD9, IB9, FE9, these cameras have H.265 technology. With this technology, you get better video quality with lower bandwidth. With H.265, it will reduce the bandwidth consumption and the storage consumption by 30 to 50% and still retain a high image quality compared to H.264. It's suitable for any application and environment, whether it's indoors or outdoors. You can see the savings here on the graph. It shows that at day and night, a significant reduction in bandwidth consumption just by using H.265 instead of H.264. And then if you combine it with VIVOTEK's Smart Stream technology, you can get even more savings in your bandwidth, up to 90% using H.265 with Smart Stream 3. Smart Codec is a Smart Stream 1 technology. It effectively reduces the quality of the whole or the non-interested area on a screen and therefore reduces the bandwidth consumed. You can manually specify the video quality for the foreground and the background areas. You can then use the auto mode, which configures the whole screen into a non-interested area, and then the video quality of part of the screen returns to normal whenever one or more objects move in that area. The remainder of the screen, where there are no moving objects or no pixel changes, will still be transmitted in low quality format, or you can manually create your regions of interest. Let me show you a demo of how this works. As you notice, all the non-interested areas are going to be sent across as very low quality, but where the gentleman is walking, you'll notice that everything is in a higher pixel and you can see everything clearly. Dynamic interframe period. So let's start off by defining iframe and pframe. An iframe or intra-coded picture is a complete image, like a JPEG image file. A pframe or a predicted picture holds only the changes in the image from the previous frame. The iframes are completely self-referential and they are the largest in size. The p-frames are predicted frames, so the encoder refers to the previous I or p frames for redundant image information. By dynamically prolonging the intervals for adding in iframes to up to 10 seconds, the bit rates required for streaming a video can be greatly reduced. If activities occur in the scene, the firmware automatically shortens the iframe or intraframe or complete picture insertion timing so that it can maintain the image quality. Smart Stream 3 includes two types of smart technologies. It first includes Smart Queue, which reduces bitrate by using real-time scene information. The scene is analyzed and then it's separated into several blocks by complexity. Each of these blocks are encoded with a compression parameter so that it can maintain the visual quality and then also reduce the bitrate. The second part of Smart Stream 3 is Smart FPS. In a static scene, the algorithm is going to put old frames in queue when no motion occurs in that scene. But when motion occurs, the encoding returns to normal to deliver real-time streaming. So by queuing the old frames from a static scene, both the computing efforts and the size of the P or the predicted frames, those are reduced. This will help to keep up with the frame rate requirements while reducing the bandwidth usage. So in our cameras UI, let's go ahead and go to video. And here I want to show you that some of our camera video modes can be changed based on your needs. For this camera, which is a 5 megapixel turret, I have 3 choices. So if I need WDR Pro, then I will have 20 max frames per second available to me. And I can choose between whether I want to use it as a 5 megapixel or a 4 megapixel camera. I'll choose 5 megapixels if I need the higher megapixels, but if I prefer widescreen 16:9 aspect ratio, then I'll select the 4 megapixel. If I don't need the WDR Pro, but I must have 30 frames per second, then I can use the camera as a 4 megapixel camera. Clicking on Stream, and then choosing Stream 1, here I can choose if I want H.265 or H.264 compression. I can change my maximum frame rates, and then I can also change my Smart Stream settings as well here. The same changes can be made to the other 2 streams that are available on this camera as well. And the final configuration I'll go over for this camera is setting up motion detection. Under Applications, we'll choose Motion Detection. We will need to make sure that we check the Enable Motion Detection box at the top and click New. And then we can plot out our 4 points for our polygon. We can adjust where our points are, change the item size for how large the item must be in order for it to trigger an alarm. And then the sensitivity, this is going to refer to how much a pixel has to change in order for it to be considered changed. Like I said before, the item size refers to the minimum size of the item to trigger an alarm, and here's how you can reduce some of your false alarms. Once we have that all set up and rename our window, we can click Save. Now that we have our camera configured, let me show you how easy it is to add the camera to an NVR, and then I'll show you how easy it is to add it to VAST. Here in our NVR's UI, we will go to Settings, and then choose Camera from the menu and Management. In order to add a camera, we will click on the Add Camera icon. It will search our network for any cameras that are connected, and then we'll click Add and Apply. Click on the Back button. Here we can rename the camera. Tell it whether to bind by MAC or IP address, and then we can enter in the camera's username and password, and then click Apply. On the top right, you'll notice that the window is spinning, and then once it's connected to the camera, it'll show an image. We can now go back to Live View and drag our camera into a view cell. Adding a camera to VAST 2 is just as easy. First, we'll log into VAST 2. Under Settings, we will go to Device Cameras. Click on the Add Camera icon, and again, it'll search our network. Once we find our camera, check the box and click Add. It'll ask us to enter the username and password for our camera. And we will get a green check mark once it's added. Here you see that it's now in our camera list, and we can go to Live View and drag and drop our camera view onto the view cell. This brings us to the end of our demo and presentation of VIVOTEK's Camera Basics. Please go to our website for more information and demo videos as well. If you have any questions, please email us at trainingna@vivotek.com.